Today, we're going to learn how to find the probability of compound events. Compound is a big word that means more than one event. We will learn to find the probability of both independent and dependent events. Independent events are events that do not influence one another. In other words, one event happening does not affect the other event. Example 1. Let's find the probability of rolling an even number on the first roll and rolling a 6 on the second roll if a 6-sided dice is rolled twice. Alright? So here goes. The probability of rolling an even number would be 3 over 6. So we would say probability even equals 3 over 6 or 1/2. Alright? That's my first roll. Now my second roll is unaffected by the first roll. The fact that I rolled an even on the first one is irrelevant. So now I'm going to find the probability of rolling a 6 on the second roll. So I'm going to go probability of a 6. Alright, well there's only one 6 on a 6-sided dice. So the probability of rolling a even on the first roll and the key word here, guys, is and rolling a 6 on the second roll. It's real simple. We will just multiply the two probabilities. Alright. Which is about 0.083 or 8.3%. Okay. So in compound probability of a independent event, if you're doing more than one event, you multiply the two probabilities. Okay? Alright. Let's find out how to find the probability of two independent events. Okay? So here we go. Let's find the probability. To find the probability of two independent events, we will find the probability of the first event, then we'll find the probability of the second one, and finally we will multiply the two probabilities, just like we did in example 1. One thing I wanted to note at this point in the lesson, that if you are performing two or more different events, you have to consider whether or not you will be replacing after the first event. The terminology that we will use in our text is with replacement and without replacement. So we're going to get a little bit more technical here in example 2. Consider these two bags of marbles. We want to find the probability of selecting a red and then selecting a blue with replacement. Alright, so here we go. The probability of red, so in red, I'll do probability of red is equal to, well, since there's just red, 2 marbles in there, and the total number of marbles is 8 plus 10 is 18 plus 2 is 20, I have a 1/10 shot, after I reduce that, of drawing a red. Now since we said with replacement, that means when I draw out of this bag, I put it back in there. So this is trial 1. Well, trial 2 is still going to have the same number of marbles in it that I had in trial 1 because I put the marble back in after I drew it out. So that's what with replacement means, and what it does is it affects your numbers a little bit. Now, the second roll, I wanted to see what happens if I select a blue. Well, there are, let's change colors here, probability of a blue is there are 8 blues out of 20 marbles. Alright, and that reduces to 4 over 10. And I could have went a little higher than that. 4 goes into there twice. So 2 out of 5. So the probability of a blue was 2/5. The probability of a red was 1/10. So the probability of both of those things happening with replacement would simply be 1 over 10 times 2 over 5 or 2 over 50, which is 1 in 25. That wouldn't be very good probability of that thing happening, would it? 1 in 25 would be about 4. Not about exactly 4% chance. That's not very good. All right. That is independent events. Well, let's talk for just a minute now about our last one, dependent events. Two events are considered dependent if the first event influences, changes, alters, etc. The second, the third, the fourth, and so on. The word to consider here is without replacement. If you select a tile out of a box that has 10 tiles in it, and you do not put this tile back, on your next selection there will only be 9 tiles. And if you don't put it back after you select it out of there on the next selection, there'll only be 8. The next time there'll only be 7. The next time there'll only be 6. So all of this will change the ratio, therefore affecting the probability. So let's consider example 3 here. Suppose you choose a letter tile from a bag containing the letter tile shown, 4 A's and 3 E's. And let's say there are 15 tiles total. Okay, 4 of them are A's, 3 of them are E's, and there are 15 total. And since I didn't write that down, I'm going to write it. 15 total tiles. And in case you're wondering right now, what are the other tiles? It's irrelevant. All we're worried about is the A's and the E's, okay? 4 A's, 3 E's, 15 total. What is the probability that you will choose an A first and then an E without replacement? All right, this is kind of cool how this works. If we're doing without replacement, probability that we'll choose an A first is going to be simple. There's 4 A's and 15 total. Okay. The probability that we're going to select an E second. Now this is where you got to pay attention to what's going on here. All right. There's only 3 E's in there still, but since we didn't put the tile back from the first run, there will be only 14 tiles left in the bag after we select the second tile, because we did not replace. Okay, we took it out and kept it out. We didn't put it back in. So 4 out of 15 A's, which will leave us a 3 out of 14 with the E's. And just like we did before, we multiply probabilities to find. So 4 times 3 is 12. Over 210. All right, let's reduce this thing on down. 2 will go in there 6 times. 2 will go in there 105 times. So that would be our ratio. That equals 0.057, which is about pretty close to 6%. So not very good probability of that happening. Alright guys, that is the way you do probability of compound events. More than one event. Okay, good job.